So let's try our hand at another function. So a little bit more maybe complicated. So let's say f of x is equal to sine of x squared. And we're going to look at the interval from say negative pi over 4 up to pi. So this is our function, sine x squared, and our interval is negative 4 to 4. And I want to find the local maximum and local minimum. So to find the local extrema, we've got to find our critical values, and critical values are where the derivative is either 0 or doesn't exist. So f prime of x, we've got a chain rule, so this is going to be 2x, and the derivative of sine is cosine, so cosine of x squared. And this function exists everywhere, right? Because x is always defined for any value, real value, and cosine is always defined for any real value. So really we just need to know when this is 0. Well, this is 0 when x is 0, or cosine of x squared is 0. Well, the only time cosine in our domain, so our domain here is, again, it's negative pi over 4 to pi. So cosine is 0 quite often on the real numbers, but restricted domain from negative pi over 4 to pi, cosine is 0 only when the input, only when x squared is equal to pi over 2. So that's when x is equal to plus or minus pi over 2, but again, negative pi over 2 is not in our domain, so it's just going to be the square root of pi over 2. So we've got our set of critical values. Again, because we're finding local, because we're only looking for local, we will disregard the endpoints. If we were looking for global, then our critical values would include the endpoints. But if we're looking for local, they only happen at interior critical values. So my maybe my interior critical values would be the set of 0 and the square root of pi over 2. So those are my interior critical values. That's where I can have local extrema. And for local extrema, I can't just compare, because it could be that they're both local maximums. I've got to use my tests. So let's go ahead and use the second derivative test, see if it works for us. So the second derivative, f double prime of x, well, I've got a product rule, right? This is the derivative of 2x times cosine of x squared. So I'm going to have to do a product rule. So it's the derivative of the first, which is 2 times the second, so it remains cosine of x squared. And then we add 2x times the derivative of cosine. Well, derivative of cosine I know is a negative, so I'm going to already put that. So this is a negative 2x times, well, I get another 2x from the interior, a 2x, and then a sine of x squared. Or kind of clean this up a little bit if you like. This is 2 cosine of x squared minus 4x squared sine of x squared. And so let's use our second derivative test and evaluate it at our critical values. So when x is 0, we can look at f double prime of 0 is 2 times cosine of 0 squared, but cosine of 0 minus, well, that's 0 and that's 0. So this is just 2. And since that's positive, this tells us that f of 0 is a min. It's a local minimum value. If it's positive, then this is a local min. On the other hand, if I evaluate f double prime of the square root of pi over 2, this is equal to 2. Now I'm going to have the square root of pi over 2, but then I put it in, it's going to be squared, so it's going to be 2 cosine of pi over 2 minus 4, and I'm getting it squared, so 4 times pi over 2 times sine of pi over 2. Now cosine of pi over 2 is 0. Sine over pi over 2 is 1. And so what gets left behind is a negative 2 pi. And that is clearly negative, which tells me that f of the square root of pi over 2 is a local max. So we've got that that f of 0. And what is f of 0, right? F of 0, so that's sine x squared. So f of 0. So let me run out of room here, but let me just kind of organize everything together. That we have a local min of, so f of 0, sine of 0 is 0. So we have a local minimum of at 0 when x is 0, and that's our min, and a local max. So if I put root pi over 2 into my function, I'm going to be looking at sine of pi over 2, so it's a local max of 1 when x is equal to square root pi over 2. So there's our local min. It's 0, and it happens when x is 0. Our local max is 1, and it happens when x is root pi over 2.